Hey, it's Michael from Mark Smarter. In this episode of How-To Dynamo, you're going to learn how to place families on a sloped surface using Dynamo. So say you're working in an auditorium and you need to place your seats in rows on a sloped floor. This is a challenge to do manually because each row is going to have a different elevation as you move up the slope. So I'm going to show you how you can use model lines to define your rows. Then we'll project those lines onto the floor surface in Dynamo. You can then generate your seat points along the projected lines. Now, what's even better is that you can do this with curved lines as well as straight lines. All right, let's switch over to Revit and get started. So I'm here in my Revit model, and I have a very simple model set up here for this demonstration. You can see I have a floor here, and this is actually a sloped floor, so it has a 1 to 12 slope on it. And then I have a bunch of model lines here that are going to represent the rows for our seating. So if I take a look in the plan view, you can see I just drew an arc and then I just copied it a whole bunch of times. So we're going to use this as our layout for our seats in our kind of theoretical theater here. Now I'm going to switch into Dynamo and we'll get started building our script. I'm going to go ahead and create a new file. And what we're going to need to do is our model lines are drawn in our floor plan level. But you'll notice if we go back into Revit, and let me go to that 3D view here, the lines themselves are not on the surface of the floor. They were drawn on level 1, so they reside right there. We want our lines to actually be on the surface of the floor because we're going to use that to generate our insertion points. So back in Dynamo, what we need to do is we need to actually project that line, that model line, down onto the surface of the floor. And again, we're going to use our arc there to generate points that we're going to use for our insertion points. So the node that we're going to use to do that work for us is in the geometry library. It's in the curves category, and we're going to go to the curve subcategory. Now the node we're looking for is called curve.project. So let's scroll down. Here it is right here. And this is a great node because it will take a curve and it will project it onto any surface that we want. So we're going to have our curve, which will be basically our model line, our arcs, and then our base geometry is going to be the floor. And then we need to pick a projection direction. So in our case, we're going to be projecting it straight down. So we're going to be projecting it in the Z dimension. So let's get all these pieces hooked up and then we can see that curve when it gets projected. Now for our curves themselves, what we're going to do is we're going to go to Revit selection, right down, where are we? Oh, sorry, we're in geometry. So we're going to go Revit selection and we're going to select model elements because we have multiple elements. So we're going to use that node right here. And so I'm going to click on select and then I'm going to switch into Revit and I'll select my model lines. Okay, so far so good. Go back in and I can see these are all the element IDs for all of those model lines that I selected. Now I also want to select my floor. That's going to be my base geometry. So I'm going to use the select model element node here and we're going to click select, switch back into Revit, and I'm going to just click on our floor. So in Dynamo, I'm going to see, again, a single element ID here for our floor. Now, I can't just connect these two nodes directly into Curve Project. You'll see Curve Project is asking for a curve, and it's asking for base geometry. So I need to do a little bit of work to get those correct inputs. Now for our model lines, I'm going to use the element get location node. So in the Revit library, we're going to go to elements, element, and I'm going to use get location. What this node is going to do is it's going to return the underlying curve from my model line. So when I connect the two and click run, you can see it automatically generates those lines here in my Dynamo preview. And if I hover under the node, I can see that it's getting the arcs. So the model line is a Revit line, but underlying that is an actual curve that defines the model line. So I need to do the same thing for our floor because I have a Revit floor, but I want to get that base geometry. Now I can do that again in that Revit element category, and I'm going to use this node here called geometry. This is going to get the geometry of that floor for me. So if I click on that, give this a run, I'll see that floor shows up right here. So now I have the inputs that I need. I have my curves from element get location, and I can plug those in. I have my geometry from the floor, and I can click that. And let me hover over here too. You can see that element geometry is returning a solid, so that's our base geometry. The only thing I need now is my projection direction. Now this is asking for a vector, so I'm going to go up to geometry, abstract, vector, and I can use this z-axis vector. So this is going to give me just a vector in the z direction. So I'm going to connect that here, and when I give this a run, I'm going to see, well, actually, I need to do a little bit of work. It actually generated just one of those projected lines. I want to get all of those projected lines. And the reason for this, let's just switch into Revit so we can actually see that. So it's giving me just that one right here. Now, I'm going to take a look at my lacing in Dynamo. And in the curve project, my lacing is set to auto. Now, lacing is going to determine what a node does when the input lists are of unequal length. So my element get location, I have 16 items. Base geometry, I have 1 item, and my vector is 1 item. So curve project is trying to figure out what am I going to do with these different lists? So it's only giving me one of those curves because it thinks I just want one, but in fact I want to get 16 of them. So I'm going to change my lacing here. I'm going to right click on the node. I'm going to set my lacing to be longest. So it's going to kind of default to the longest list. And if any of the elements of the input lists that are not as long as the longest list, it's just going to repeat that element. And again, I have 16 curves. I have 1 base geometry and 1 vector. So I want to repeat my geometry and my vector for all of the 16 curves. So if I give this a run, you can see it filled out the rest of those projected curves. And I can see it better if I switch into Revit. So I can see if I look, and I'm using dark mode and I have dark blue lines, so it might be hard to see, but I now have 16 curves on the surface of my floor, which is exactly what I wanted. So that's our kind of first step here. Next, what we're going to do is we're going to actually generate our points along those curves that we projected. So to do that, I'm going to do a couple things. I'm going to take a look at my list here from Curve Project. And one thing you'll notice, let me zoom in, is that I'm getting 2 curves for each curve that I'm projecting. You'll see they're coming in as an ellipse arc. And if I look at them, they're basically identical in the X and Y, but the Z, the Z is coming in the same as I go down there as well. So what I need to do though is it's giving me kind of the top and bottom. So let me take a look. If I spin around my geometry here, let's try that again. And let's see if we can see the underside of this a little bit better. My preview is a little slow here. Let's see if we can get under there. Come on, Dynamo. I don't think it really wants to. I'm recording this on a Saturday morning, and I think Dynamo is just like, man, I'm tired. So all that to say, I am getting these 2 curves here, and one is representing the top surface of that floor, and the other represents the bottom surface. So it's projecting onto the top and bottom surfaces. Now, what I want to do though is I only want to get 1 curve. I obviously don't want to put seats on the bottom surface of that floor. So I'm going to use a get item at index node. If I go into list and I'm going to inspect, and here's get item at index. Because in the end, what I want to do is I want to just get 16 of those curves. I want 1 version of each projected curve. So from curve project, I'm going to connect that into get item at index. And the index that I want to get, I'm going to use a code block here. I just want that first curve. And I just want the first curve though from each set. So if I click run and I hover over my output, you'll see it's giving me actually 2 items here. It's giving me these first 2 curves. Now the reason for this is because what I want to do though, I want to get the first of each sublist. So I have nested lists, so a list with lists inside of it. So using get item at index, if I don't kind of do anything and I use it as the default, it's going to get me this first sublist right here. But what I want though is I want to get the first item of each of those sublists. So to do this, I'm going to click over here on list. I'm going to choose use levels, and I'm going to use that level 2. So if I'm looking in here on my output of curve project, what I want to do is get that second level. So we're going to target that second level of the list. So what that should do, if I give this a run now, is it's going to give me actually 16 items instead of just 2. So I'm getting item 0, item 0, item 0, all the way down for all of my nested lists. Okay, so now that we have those lists, we have those actually projected curves. Now, I want to generate some points along those curves, and we're going to use those for our insertion points for our families. So I can do this going to Geometry, Points, Point, and let's see, Geometry. I'm sorry, I want to go to, my bad. I'm going to go Geometry, Curves, Curve. Points and curves are very different. And the node I'm going to look at specifically is this one, points at equal segment length right here. You can see there's a lot of similar point at nodes. So we have point at parameter, point at segment length, point at equal segment length. So that's the one that we're going to choose. And when we click on that node, I have an input, that's the curve, and then I have an input for a number of divisions. So this node is going to subdivide my curve based on the number of divisions. So they will equally space the number of the points along that curve. So I'm going to click in our get item at index node here. Let me close out of these, or I'm going to just close these outputs. Now for divisions, I could use a code block. I'm going to do something a little more fun. I'm just going to use a slider, and I want to use an integer slider because I don't need decimal points. And let me set that, I'm going to set that for, I will set it for 25 to start. So that's going to be my divisions right there. So if I give this a run, and let me see if my preview is acting a little bit better. It is, slightly. And if I zoom in, I can see all of those insertion points that I have right now. And I just want to verify, yes, so I'm creating all of those points along those projected curves. And this gives us a good view of what our auditorium is going to look like. So now I have a whole series of points. So I'm pretty much ready to start inserting the family. Now, I'm going to use, to insert the family, I'm going to go into Revit, and I'm going to use Elements and Family Instance. And we'll use the, let's see, we're going to use the by point node right here. We have a lot of options for this. I'm going to show you why we're using by point in a second. So my inputs are going to be the family type and the point. So we're going to take our list of points from points at equal segment length, and our family type we're going to get from Revit selection, and we're going to use the family types node right here. So family types will allow me to actually select a family that's in my model. So I have a family in here which is called theater seat. Let's grab that right here. So that's going to be our family type. And I'm going to do a split screen. So I have Revit and Dynamo up. I have all of my points. I have my family selected. I'm going to go ahead and hit run. And Dynamo is going to insert all of those families in those points. And you can see it's following that surface of my floor, and I'm getting my kind of curves in here as well. Now, one thing to note, the rotation is not correct. So I'm going to go ahead and back in our Revit or family instance subcategory. Let's find that, Revit elements, family instance. There is a node here that allows me to rotate the family instance as it gets placed. So I'm going to use the set rotation node here. So after the family gets placed, I can set its rotation, and we're going to set that to be, I believe 270 is going to work. I'm going to click that in, we give this a run, And you can see it rotated all of those family instances 270 degrees. So they look a lot better. You'll notice that though that they have a uniform rotation, so they're all facing kind of front. Now, if I'm designing a theater or an auditorium, I probably want to rotate each of those chairs a certain amount to follow along that arc. Now, I'll show you how you can rotate elements along a curve in a future episode of How to Dynamo, but just know that it is possible to have that varying rotation. Now, one other thing to note is that the family that I'm using here is a generic family. So if I go ahead and edit the family, this is a family that I created. You want to pay attention to the family that you're using, because in this case, I'm inserting those families using a point. I don't want them associated to a level, because otherwise they'll come in all flat across the level here in Revit. Instead, I want to use a point family. So a generic model family worked out well because I can position it with an XYZ point. So know if you try using a furniture family, you might actually have to kind of modify that family or copy and paste it into a new family that will allow you to position it by that XYZ point. I had to do a lot of back and forth to get my family just right so that it would follow along those curves with the varying elevations. All right, so that's all for me. Let me switch back here. We'll take one last look at our, cancel that, at our final design. And leave a comment if you have any questions, and hope to see you soon. Bye. Thanks for watching. I hope you enjoyed this episode of How to Dynamo. If you did, go ahead and click the subscribe button to get more Revit automation tutorials. Also, check out my free Dynamo template using the link over there. This template contains 20 node groups for common Dynamo actions, and it'll save you a ton of time when you're creating your scripts. Just copy and paste the groups you want, and you're on your way. All right, that's all from me. I hope to see you soon. Bye.